students. Last class we have discussed about measurement. What is measurement? Comparison of two physical quantities with standard units, we can call it as measurement. Then we discussed about physical quantity. In that, laws of physics are described. Length, mass, time are the examples for physical quantities. Then types of physical quantities. There are two types of physical quantities. One is fundamental quantities, the other one is derived quantities. What are fundamental quantities? Length, mass, time, electric current, temperature, amount of substance, luminous intensity. Then derived quantities are velocity, area, acceleration, etc. Then you study units. In that there are two types of units. One is fundamental units, another one is derived units. Then you study system of units. There are three system of units: FPS system, CGS system and NKS system. FPS system. F stands for foot, P stands for pound, S stands for second. Then CGS system. C stands for centimeter, G stands for gram, S stands for second. The last one is NKS system. Here N stands for meter, K stands for kilogram and S stands for second. This FPS system is a British engineering system. Then CGS system is Gaussian system. This CGS system and NKS system we will be calling it as metric system. Why we are calling it as metric system? In the sense, it can be expressed in the form of powers of 10. For example, 100 centimeter I can write as 10 power 2 centimeter. Then advantages of SI system. There are three advantages of SI system. One is rational system of units. Second one is coherent system of units, and the third one is metric system of units. Today we are going to discuss about SI based quantities and its units along with its definition. It is given in your textbook, page number 9. Here it is very important 2 mark question. Out of this 7, they may ask one question in 2 mark. Here, when you are writing the definition, you must write what is given in your textbook as it is. Now, we will discuss about one by one, and first we will see about length. If I take length, the unit for length is meter and the symbol is m. We know that the speed of light is 3 into 10 power 8 meter per second. Accurately, if I want, the speed of light will be 299.792458 meter per second. How I can read this number? 299,792,458 meter per second. Now, my question is, what is my question? To define 1 meter. Now, for 1 second, so much meter. I can rewrite like this. 1, that is second. Here I will write meter. For 1 second, it is for 1 second, 299,792,458. Our question is to find out for 1 meter. So for 1 meter, how much seconds? So you cross multiply this 1 into 1, 1 divided by this number. So how much seconds? Now I can define 1 meter. 1 meter is the length of the path. Is the length of the path traveled by light. In vacuum. So 1 meter is the length of the path traveled by the light in vacuum is equal to 1 by 299,792,458 seconds. This is definition of 1 meter. This clear now? Now we are going to mass. The unit for mass is kilogram and the symbol is kg. Now we can define 1 kg, that is 1 kilogram. 1 kilogram is equal to mass of platinum and iridium cylinder. Mass of platinum and iridium cylinder whose height is equal to the diameter. Whose height is equal to the diameter. So I will repeat. 1 kilogram of mass is equal to platinum iridium cylinder whose height is equal to the diameter kept at International Bureau of Weight and Measures. International Bureau of Weight and Measures near Paris at France. It is clear. Now we are going to time. So unit for time is second. Symbol is S. Let us consider cesium 133 atom. So cesium 133 atom. This 133 represents the atomic mass. What will be the atomic number for cesium? It is 55. The atomic number for cesium is 55. Now we will draw the electronic configuration for the cesium, the atomic number 55. The electronic configuration is 2, 8, 18, 1. So 8 4s are 32, 33, 35. So 3, 4 plus 1, 55. So 2, 8, 18, 8, 1. Here how many shells are having? 6 shells. In the outermost shell we are having only 1 electron. In the outermost shell we are having only 1 electron. Now this 1 electron has kept in the ground state. This 1 electron has been kept in the ground state. Now photon of energy h nu observes this electron and it will take to the excited state. It will take to the excited state. So the photon of energy h nu, it will absorb this electron and it will take to the excited state where that electron will oscillate or vibrates. It will oscillate or vibrate in between. It will oscillate or vibrates in between two hyperfine levels. It will oscillate in between two hyperfine levels, and then it will emit or it will produce radiation. It will produce radiation, and that radiation is in the form of waves or in the form of particles. Now let us consider a wave. For this full wave, it takes a time period of t. For one wave, the time period is 1. Now, in all these waves, if all these waves covers so much periods, if all these waves covers so much periods, then I can call it as 1 second. Understood? So, how I can read this one? 9 billion 192 million 631,770 periods. It is clear. Now, we are going to electric current. The unit for electric current is ampere and the symbol is capital letter A. Let us consider two infinitely straight conductors. Let it be white, separated by a distance of 1 meter apart. Separated by distance of 1 meter apart. Now, let us consider is the current flowing in this conductor as well as in this conductor. So, in a conductor, if current is supplied, what will happen? Magnetic field will be produced. So, magnetic field will be produced. What will be the direction of the magnetic field? How to calculate or how to find? For that, we must use right hand thumb rule. Now, let us take this one, that's right hand thumb rule. This thumb represents the direction of the current. This thumb represents the direction of the current. These curled fingers, okay, these curled fingers represents the direction of the magnetic field. Now, the attractive forces between these two conductors, the attractive forces between these two conductors is 2 into 10 power minus 7 Newton per meter. Is 2 into 10 power minus 7 Newton per meter. That is called 1 ampere. I think it is clear for you now. Now we are going to discuss about thermodynamic temperature. The unit for temperature is Kelvin. Symbol is K. Now I want to define 1 Kelvin. Let us consider this graph, temperature against pressure. We are having 3 curves, 1, 2 and 3. So these 3 curves meet at one particular point. What we can call it as triple point of water. So this one is solid state, liquid state, gaseous state. Example, ice, water, water vapor. So solid means ice, liquid means water. Then water vapor means gas. Now, what is triple point of water? If water exists in 3 phases, that is solid, liquid and gases, then I can call it as triple point of water. Now, what will be the temperature at this triple point of water? It will be 0.01 degree Celsius. You will have what? 0.01 degree Celsius. Now, how to convert degree Celsius into Kelvin? So, degree Celsius plus 273.15 will be Kelvin. What is degree Celsius here? 0.01. 0.01 plus 273.15. If I add this one, I will be getting 273.16 Kelvin. I will be getting what? 273.16 Kelvin. Now, I can define 1 Kelvin. 1 Kelvin is fraction of, listen, 1 Kelvin is fraction of thermodynamic temperature of triple point of water. This will give definition of 1 Kelvin. I will repeat. So 1 Kelvin is nothing but fraction of thermodynamic temperature of triple point of water is called 1 Kelvin. I think you understood. Now we are going to amount of substance. The unit for amount of substance is mole and the symbol is MOL. For example, you take 12 gram of carbon 12 atom, or I can write this 12 gram as 0.012 kilogram of carbon 12 atom. What is amount of substance? Number of atoms present in a given substance is called amount of substance. That is, number of atoms present in a given substance is called amount of substance. How to calculate number of atoms? So we know that number of atoms is equal to 6.022 into 10 power 23. You already come across this number. This is nothing but Avogadro number. This 6.022 into 10 power 23 is nothing but Avogadro number. Now, how to find out the atoms? Number of atoms present. Number of atoms in 1 mole of a given substance. Of a given substance. Let it be gold. Example. So, number of atoms in 1 mole of a given substance is equal to number of atoms in 1 mole of carbon 12 atoms. I will repeat. 1 mole is nothing but what? Number of atoms in 1 mole of a given substance, for example gold, is equal to number of atoms in 1 mole of carbon 12 atoms. Understood? Now we will go for luminous intensity. The unit for luminous intensity is candela and symbol is CD. Let us consider a monochromatic source. Mono means single, chromatic means single, chromatic means color, single color. This monochromatic source emits radiation and it has a frequency 5.4 into 10 power 14 Hertz. It has a frequency 5.4 into 10 power 14 Hertz. We know the formula for luminous intensity, that is luminous intensity is equal to luminous flux divided by solid angle. So luminous intensity is equal to luminous flux divided by solid angle. We will discuss about solid angle later. Now the formula for luminous flux or a symbol for luminous flux is phi, and for solid angle it is omega. Symbol for luminous flux is phi, and for solid angle it is omega. Now the unit for flux lumina, and for omega it is steradian, SR. The symbol is SR. So steradian. Now the value for pi is 1 by 683 watt. 1 by 683 watt, and omega that is 1. So totally we have 1 by 683 watt per steradian. Because the unit is 1 steradian. So watt this steradian, if it comes out, this watt per steradian. This will give luminous intensity, that is candela. Understood? So today we are seeing SI base quantities and its units along with the definition. The length meter, symbol is m. 1 meter is the length of the path travelled by light in vacuum is equal to 1 by, that is the fraction of that second. Next, mass, the unit is kilogram, symbol is kg. 1 kg is equal to mass of platinum iridium alloy of cylinder whose diameter is equal to height kept at International Bureau of Weights and Measures near Paris. Next, we studied about time. The unit is again, symbol is S. All these waves, that is all these waves, if it covers so much periods, so much number of periods, then I can call it as seconds. Then we studied about electric current, ampere, symbol A, attractive forces between two conductors, that is two parallel conductors, is 2 into 10 power minus 7 Newton per meter. Next, we discussed about thermodynamics, temperature. Unit for temperature is Kelvin, symbol K. The fraction of thermodynamic temperature of triple point of water is called 1 Kelvin. Next, we have discussed about amount of substance. Unit is mole, symbol is MOL. Here, number of atoms in 1 mole of a given substance is equal to number of atoms in 1 mole of carbon 12 atom. The last one is luminous intensity. That is luminous intensity is nothing but 1 by 68 watt per second. This will give the luminous intensity. I think this is clear for you. Now we are going to discuss about supplementary quantities. It has two types, plane angle and solid angle. This supplementary quantities was converted into derived quantity in the year 1995. Now we are going to discuss about plane angle. Let us take two straight lines. They are intersecting at one particular point, what we can call it as angle theta. Like that, we take two planes. It intersects at one particular point, makes an angle theta. This intersection, what we can call it as plane angle. That is angle made at the intersection of two straight lines, or it may be of plane. Is called as plane angle. It is two-dimensional figure. It is two-dimensional figure. Now let us consider a circle. of radius r. On the circumference of a circle, let us take a small arc AD. Let us take a small arc AD of length ds. Of length ds. This arc length subtends an angle d theta. It subtends an angle d theta at the center of the circle. This arc length subtends an angle d theta at the center of the circle. Now I can write d theta, that is angle, is equal to what? How this angle formed? Arc length by radius. So I can write ds by r. What is the unit for s? Meter. Radius, meter. If I cancel this, there is no unit for d theta. That is dimensionless. But to specify the measurement, we give a specific name for this ratio. We will give a specific name for this ratio named radian. Named as radian, and the symbol is RAD. This radian is the unit for plane angle. So what is the unit for plane angle? Radian, and the symbol is RAD. So this I can rewrite as theta is equal to S by R radian. Theta is equal to S by R radian. If S is equal to R, now this equation will become theta is equal to, in the place of S, I will be writing R, then divided by R radian. This R and R cancels, so theta is equal to 1 radian. Theta is equal to 1 radian. Now I can define the radian. The radian, that is 1 radian means, 1 radian is angle subtended. 1 radian is what? Angle subtended at the center of the circle by what? By whom? By the arc length, whose arc length is equal to the radius of the circle. See here, angle subtended at the center of a circle by an arc equal in length to the radius of the circle. This is the definition of the radian. Now we will see the relation between radian and degree. We know that if you take an hemisphere, the overall the angle is 180 degree. Now this is one sector. This is one sector. So here this is one sector, this is one sector, and this is another one sector. So I can write this one is what? 1 radian. Up to this 2 radian. This 3 radian, and then this gap, this will be equal to 0.14 radian. 0.14 radian. If I add all these things, I will write 3.14 radian is equal to 3.14 radian is equal to 180 degree. Now I want to calculate for 1 radian. In this 3.14, I can write it as pi. So pi radian is equal to 180 degree. Therefore, 1 radian is equal to 180 divided by pi. What is the value of pi? 180 divided by 22 by 7. Take this 7 here, it will give 187 by 22. That is equal to 57.27 degree. So 1 radian is equal to 57.27 degree. Next we will be going for degree into radian. Degree into radian. Pi radian is equal to 180 degree. So reverse. So 180 degree is equal to what? Pi radian. Therefore 1 degree is equal to pi by 180 radian. Pi by 180 radian. Understood? So we know what is the value of pi? 22 by 7 divided by 180. 22 by 7 divided by 180. So I can write 22 by 7 into 180, that is equal to 1.745 into 10 power minus 2 radian. 1.745 into 10 power minus 2 radian. So I can write 1 degree is equal to 1.745 into 10 power minus 2 radian. Similarly, I can calculate 60 minutes is equal to 1 degree. 60 minutes is equal to 1 degree. 1 minute is equal to 1 degree by 60. That is, what is the value for 1 degree? 1.745 into 10 power minus 2 divided by 60. So, we will be getting as 2.91 into 10 power minus 4. If I simplify this, I will be getting 2.91 into 10 power minus 4 radian. So 60 minutes is equal to 1 degree. Therefore 1 minute is equal to 1 degree divided by 60. We know the value of 1 degree, that is 1.745 into 10 power minus 2 divided by 60. If I simplify this, I will be getting 2.91 into 10 power minus 4 radian. I will be getting 2.91 into 10 power minus 4 radian. Next, we will calculate for 1 second. For 1 second will be equal to 1 degree divided by 3600 second. So 1 degree, what is the value for 1 degree? 1.745 into 10 power minus 2 divided by 3600. Understood? Now we will be getting 4.847 into 10 power minus 6 radian. I will be getting what? If I simplify this value, I will be getting 4.847 into 10 power minus 6 radian. So I can rewrite it as 4.85 into 10 power minus 6 radian. Is clear? So now we are going to discuss about solid angle. So in solid angle, that is angle formed by 3 or more planes where intersecting at common point. So if you take 3 planes, these 3 planes will intersect at one particular point and it makes an angle. That angle what we can call it as solid angle. For example, square, cuboid are all solid angles. Now it is 3-dimensional figure. Now let us consider a sphere of radius r. Now on this sphere, just you take a small area dA. Now you join these two things. Now it makes an angle d omega. It makes an angle d omega. So now I can define this d omega is equal to dA by this one or this one or, so it is r square. The unit for area is meter square and for radius it is meter. We are having 2 radius, so meter into meter, So we will be getting meter square. This m square and m square will be cancelled. So no unit. But to specify the measurement, we must give a specific name for this ratio. And they given a name as Radian. And the symbol is SR. So I can write omega is equal to A by R square steradian. Now, this steradian unit is for solid angle. That is, for solid angle, the unit is steradian. Now, I am going to define one steradian. That area is equal to 1 meter square and radius is equal to 1 meter. Then solid angle is omega is equal to 1 meter square by 1 meter into 1 meter. So we will be getting 1 meter square steradian. So it will cancel. So omega is equal to 1 steradian. Omega is equal to what? 1 steradian. Now you see the definition of 1 steradian. 1 steradian is what? 1 steradian is angle subtended. By what? The area is 1 meter square and the radius is also 1 meter square. So the subtended of a sphere by that surface of the sphere is equal in area to the square of radius. This is about definition of steradian. So today we will stop up to this. So what are the topics we are discussed? First, SI base units and its definition. That 7 fundamental quantities. That is length, mass, time, electric current, temperature, amount of substance, luminous intensity. Then we discuss about supplementary quantities. In supplementary quantities, plane angle and solid angle. So we define about plane angle. Then we discuss about conversion of radian into degree and degree into radian. Then minutes into radian. Then seconds into radian. Now afterwards we discuss about the solid angle. Thank you.